Alright, so good night to each and everyone, and welcome to Moyo Math, day 4 of our past paper prep sessions. Tonight, what I'm going to do, I'm going to review variance and circle theorems. Now, in session 1, we had some issues with the video. The video lagged a bit, and hence students weren't able to benefit from these two key topics, the information in relation to those two key topics. So I've decided to redo day 1 and to also go through each question thoroughly in this presentation on circle theorems and variance, right? Past paper questions in relation to those two topics. So tonight we are going to delve into these two key topics. So the exam is on Monday. Tomorrow will be our last session, and tomorrow I'll try my best to cover as many topics as possible. So tomorrow maybe a bit of a marathon run, yes, and maybe conducting the classes at a later time, so the time span will be much more. So we'll start at an earlier time, but the time span will be much more. So instead of being 2.5 hours, we'll probably do about 5 hours, yeah? So we can cover as much as possible to prepare for the exam on Monday. So let's get into variance and circle theorems. Alright, so I encourage you to tell your friends to like, share, and subscribe to the channel. And let's get into it. So with your circle theorem and your variance, we know this is a very important topic. We expect to see a question in relation to circle theorems in question 9 of the examination paper. And in order for us to answer this question, well, because many students have challenges with this question, but in order for us to answer this question, well, it requires you to know your theorems. You have to know all your theorems in order to answer this question effectively. So as we do each question, I'm going to pull out from the diagram the theorem that is applicable to the specific part of the question, and we are going to show how the theorem will be used to help us to get the answer. Alright? So I hope we know our theorems, I hope we're reviewing our theorems, and let's get into this first question here. So it says here, K, L, M, N are points on the circumference of a circle with center O. So O is always the center of the circle. X, Y is a tangent to the circle, so X, Y is a tangent to the circle at K. K, of course, is known as your point of tangency. That's where the tangent meets the circumference of the circle. Angle LKY, so angle LKY, so we have LKY is 48 degrees. And keep in mind, when you have an angle, the letter at the middle is where the angle is located. So we have here K at the middle, so our angle will be located at K. And of course, K will be known as your fixed point, and the two lines that connect at your fixed point will be your KL in this case, and KY. But the letter in the middle is where the angle is located. So angle LKY is 40 degrees, angle MKO is 12 degrees, again, MKO. So we're looking at the angle being formed at K, but between the two lines, KO or OK and MK or KL. So you see OK and KM. So angle there is 12 degrees. So angle MKO 12 degrees. And angle XKN 56 degrees. So XKN 56 degrees. Again, K is where the angle will be located. That's in the middle, but between the two lines, XK and KN. So ensure that we can recognize where the angles are located and understanding when we name angles, how we can locate that angle on a diagram. So with this question, they want us to find the value of angle KOL given reasons for each step of your working. So we want to find angle KOL. So let us recognize first where is angle KOL. So we want us to find angle KOL. So we have to find angle KOL. So part 1. So that symbol I have on top of O represents angle. Okay, so you want to find angle KOL. So let's first identify where that angle is located. So we're looking at the letter in the middle, O, and of course the two lines, O will be the fixed point, and the two lines will be KO and OL. So we're looking at angle KOL. So this is our angle here. Alright, so that's angle KOL. And to find that angle, what are we going to do? We know with circle theorems, we must know our theorems again, one, and we must know some basic principles as well that are applicable to circle theorems. One will be the use of the isosceles triangle, which we clearly see in this diagram. And what's an isosceles triangle? Remember, an isosceles triangle will be a triangle where two sides are equal. So we have two sides equal, and two base angles are also equal. So this angle is x, that angle is also x. So the two base angles are equal. So we have here the triangle OKL, and we want to find angle KOL, which is this angle here. Alright, so I've taken out the triangle from the diagram itself, and this is the angle we need to find. So to find that angle, what are we going to do to help us? We are going to first work towards finding the base angle of that isosceles triangle. And once we determine what's the base angle of that isosceles triangle, then we are able to find the angle at O, KOL. Right? So how are we going to find the base angle in that isosceles triangle? So if we look here, one of the theorems that will be very helpful in us finding the angle KOL will be this theorem here. And let's make sure that we can recognize this term because it's used regularly. If I have here a circle, this is my center, this is a radius, this is a tangent, note the angle between the radius and the tangent at the point of tangency. So this is O, this is K, and this is Y. So I pull it out from the diagram, OKY. The angle between the radius and the tangent at the point of tangency is equal to 90 degrees. Okay? So this angle here is 90 degrees. You see that angle? So OKY is 90 degrees. And if that angle is 90 degrees, then we are now able to find easily the base angle within that isosceles triangle by simply subtracting 40 from 90, which will help us to determine this base angle here, right, at K. So this is OKL, we're able to find that base angle. And once we find that base angle, then that will certainly help us to find the angle KOL. Alright? So that's what we want to determine, the size of that angle. That's the objective. So let us determine what is the base angle OKL. So I'm going to call it OKL. So angle OKL, so this is my solution here. Right? So we're looking at part A. So our solution is, I'm going to begin by stating angle OKL, which is this angle here, one of the base angles of the isosceles triangle, will be equal to 90 subtract 48. So we are going to subtract 48 from 90, and when we subtract 48 from 90, we are going to get what? This will give us 42 degrees. So we know that this angle here will be equal to 42 degrees. Alright? So this angle within my isosceles triangle, this angle here, it is 42 degrees. Alright? So that angle is 42 degrees. And once this base angle is 42 degrees, then this base angle on the adjacent side will also be 42 degrees. And once those two base angles are 42 degrees, what we can do is easily determine our angle KOL. So we know that angle KOL, which is the angle we want to determine, will be equal to 180 degrees subtract 42 plus 42, because we know the sum of three angles of a triangle will give us 180 degrees. So this will be 180 degrees. Subtract, that will give us 84. And we know 84 from 180, that will give us what? 180 subtract 84, that will be 96 degrees. So angle KOL, which is this angle we have to determine, angle KOL, this angle we have to find, which is part one of the question. So they ask us to find angle KOL given a reason for each step of your working. Alright? So reasons will be, and reason for each step. So let's include our reasons as well. So the reason will be, we found angle OKL, yeah, by subtracting 48 from 90 degrees, yeah, and we found angle KOL by using the fact that the sum of three angles of a triangle will give 180. So we're going to include here as our reason. Our reason will be 1 base angles of an isosceles triangle equal, and the sum of three interior angles of a triangle is 180 degrees. Alright? So we want to ensure that we give our reason. And what I will also include in terms of our reason for angle OKL being equal to 42 degrees, and I will include the fact that the angle between the radius, so I'll include this theorem as well, the angle between the radius and the tangent at the point of tangent C is 90 degrees. I will also include that as part of my reason, because they ask us find angle KOL given reasons for each step of your work, each step. Alright? So we're showing each step here. So the fact that we got 42, by subtracting 48 from 90, and because of this term that is applicable, and the fact that it is an isosceles triangle, and the sum of three angles of a triangle will give 180 degrees, right? Given all the reasons. Alright, so let's move on to part 2 of this question. So they want us to find angle LMN. Angle LMN. So let's locate angle LMN. Okay? So let's find that angle on the diagram. Let's locate it, and then we can proceed to find it. So I'm going to erase this information here. So I'm erasing this information. And we're looking at angle, so this is part 2, A. We want to find angle LMN. Good? So let's find that angle LMN. So the first thing we want to do is locate that angle on our diagram, LMN. So remember, the letter in the middle is where the angle is located, and of course M will be your fixed point, and that fixed point will occur between the lines LM, so LM and MN, right? So this is our angle here. So that is your angle LMN, which we need to find. So the good thing is, in this part of the question, they ask us to find the value, not to give a reason, but you have to know your reason to determine the size of the angle. So let's identify the reason, and of course use it to help us to find the size of that angle. So if we look at this diagram, and this is something very common that they bring, you see here this four-sided figure. Alright, and if you look at that four-sided figure called a quadrilateral, each vertex of the quadrilateral touches circumference of the circle. So one time you know that quadrilateral is called a cyclic quadrilateral. So get familiar with that, right? Make sure you look out for that because it comes regularly. So I'm going to put out here the cyclic quadrilateral. So this is N, M, L, K, N. So we have that cyclic quadrilateral there that I've taken out from the diagram. And we want to find this angle here, LMN. So how are we going to find that angle? And again, it requires us knowing our theorems. So there are two important terms that are applicable to a cyclic quadrilateral. And one term is opposite interior angles. These are all interior angles, all angles inside of this cyclic quadrilateral are called, interior angles. So this is one interior angle, and this here opposite to the angle LMN, opposite to that angle, we have another interior angle within the cyclic quadrilateral. And the term simply states opposite interior angles of a cyclic quadrilateral are supplementary, meaning these two interior angles must add to give 180 degrees. So if we know one angle, we can determine what is the other. So this angle here, which is angle LKN, or you can call it NKL, whichever you wish to name, we can find that angle. Yeah, we can find that angle within the cyclic quadrilateral, which in turn can help us to find angle LMN. So let's get this angle here. So this angle is what we're looking at. So I'll erase this 42 degrees. And let's find this angle here. See that angle? I want to find that angle, this angle here within the cyclic quadrilateral. And that can be easily found because if you look, this is a straight line. Hence, a straight angle exists, which is equal to 180 degrees. So what you can do, you can add 56 to 48, and we subtract that from 180 degrees to give us this angle here, which is NKL or LKN. Any of the two we can name. So, the angle. So, let us find, I'm going to state here first, I'm going to find, let's show you the steps, angle NKL will be equal to 180 degrees, subtract 56 degrees plus 48 degrees. That's 180 degrees subtract, and 56 plus 48 will give us what? 104. So we're going to subtract 104 degrees from 180. So 180 subtract 104 will give us 76. So this angle here is 76 degrees. This angle here within the cyclic quadrilateral, it is 76 degrees. And knowing this angle, what we can do now is determine the angle LMN. So therefore, angle LMN is equal to 180 degrees minus 76. And 180 subtract 76 will give us what? 180 subtract 76 will give us 104 degrees. So the angle LMN is equal to 104 degrees. Alright? So making sure we know how to find that angle, alright? So very important to circle terms. We know certainly this will come in the exam on Monday, and let's make sure we can recognize the term and apply it to find our angles. So this part B, they want us to find angle KLO. So we found angle LMN, let's find angle KLO part 2. So angle KLO. So KLO, so I'm going to erase this information so we can find angle KLO. So let me erase. So looking at angle KLO. So again, the first thing we need to recognize where that angle is located on the diagram. KLO. Again, L is the letter in the middle. That's the fixed point of your angle, where the angle is located between two lines, KL and LO or OL. So that's all. KLO, L is my fixed point, and of course the fixed point occurs between KL and OL or LO. And this here will be your angle. So that's the angle we need to find. And how are we going to find that angle? Straightforward. This here, as we all know, this is OKL. We just showed that this triangle is isosceles, and we got one of the base angles here to be what? 42 degrees. So if that base angle is 42 degrees, it means that angle KLO, this angle here, will also be 42 degrees, because this triangle is isosceles. My two sides are equal, and hence my base angles are equal. So I can state here that angle KLO, so angle KLO is equal to 42 degrees. Yeah? And that will be part B. So this is part B. Right? Angle KLO. Let's move on now to part C. So let me go back to the diagram. So part C, they want us to find in part C angle MLK. So part C, angle MLK. So I'm erasing this here. So part C, we want to find angle MLK. Good? MLK. Yeah? So again, where is that angle located? MLK. Okay? So MLK is located here. So MLK is this angle. So let me erase this here. So we're looking at this angle here. So that is angle MLK. It occurs, of course, L is your fixed point. So that's where the angle is located between two lines, ML and KL. So we know this is our angle we're looking at here. So how are we going to find that angle? Now if you look carefully, this angle falls within a triangle. The triangle is what? This triangle here, MKL or MLK, however you choose to name it, right? So I'm going to pull out that triangle, M, L, K, right? So I've taken out that triangle, and this is the angle we need to find. So how are we going to find that angle? Now to find that angle, what we can do is, because it's a triangle, if we can find these two interior angles of that triangle, then we can add those two interior angles and subtract it from what? 180. But what those two interior angles, what they are equal to, and let's look carefully. So we saw earlier that let me erase this here. We saw earlier that this angle, that base angle within the isosceles triangle is 42 degrees. We calculated that earlier, alright? So if this angle here is 42 degrees, alright, that's the base angle of the isosceles, then this little piece here within that triangle, that angle within that triangle, that little angle there within that triangle, we can determine by simply subtracting 12 from 42. If we subtract 12 from 42, then clearly we can find this angle within the triangle. Alright, so this entire base angle is 42. This little piece here, that little angle there is 12 degrees. And therefore I can subtract 12 from 42 to give me 30 degrees. So I know that this angle here, it is 30 degrees. Okay? So easily we can find that angle within the triangle. And what about this angle up here? How are we going to find this angle up here now? Alright? So to find that angle, what are we going to do? Let me erase this part here. So we want to find this angle here. So how are we going to find that angle? Okay? And this is where we can use one of two theorems to help us to find that angle at M. And what I'll do is I'll pull out the two theorems so you can see what the two theorems are, and any one can be used to help you to identify what is the size of the angle at M, this angle here. Alright? So I'm going to pull it out. So the two theorems we can see are, so I have my circle. So let's recognize this first theorem. This is the center. I have this arc length from K to L. So let me put K here. Let me put L here. So that arc length from K to L, what it will do, it will subtend, and subtend means to simply create, it's going to create this angle at the center. So draw a line from K to the center, draw a line from L to the center, so we have this angle here formed. Good? So that angle formed at the center. But that same arc length from K to L, that same arc length, will also subtend Sub 10 again, we're going to create another angle, but this time this angle will be created at the circumference. And I'm going to call this, of course, this is M. Yeah? Alright? So this angle at M here can be easily found based on this theorem, which simply states, and remember we got the angle at the center previously to be 96 degrees. So if that angle is 96 degrees, we can easily find this angle at M. Good? By using this important term, our arc length from K to L will create that angle at the center, which is 96 degrees. And the arc length from K to L will create this angle or subtend that angle at the what? Circumference. And we need to know, once we see that occurring, the angle at the center is always twice the angle at the circumference, subtended by the same arc, or created by the same arc. Yeah? So therefore, a half of 96 will give us 48. So this angle here will be 48 degrees. So let me put it in black. So that angle at M will be 48 degrees. This angle at the middle, at O, is 96 degrees. So half of 96 will give us 48. So I know that this angle at M here is 48 degrees. Okay? So that's one theorem we can use to help us to determine the angle at M. So you see, it's about looking at the diagram, recognizing the terms, and using it to help you. We can also use this theorem. This is a very common theorem we see in the exam. So this is the theorem. So we can also use this to find the angle at M. So I have a chord. That chord is drawn from K to L. So remember, chord is a line drawn from one end of the circumference to the other end, but it does not pass through the center of the circle. So that is a chord. And this here is a tangent. Now the term we need to know is this. The angle between the chord and the tangent, this angle here, which is, as you clearly see from the diagram, it's 48 degrees. Right? So the angle between the chord and the tangent is always equal to the angle that the chord subtends. So the chord is going to subtend or create an angle here at the circumference, M. So this angle between the chord and the tangent, which is 48 degrees, is equal to the angle that the chord, this chord is going to subtend. A line drawn from K, a line drawn from L, both lines drawn to meet at the circumference M. This angle here is formed. And that angle formed will be 48 degrees also. Alright? So the angle between this chord and this tangent is equal to the angle that the chord subtends at the circumference. So this angle here will be 48 degrees. Okay? So having found that angle, right, and show you two methods or two theorems we can use to help us to find that angle, we can now find the angle MLK. Alright? So they're showing you what terms we use to help us to find angle MLK. So therefore, let's find angle MLK now. So angle MLK will be equal to sum of three angles of a triangle will give 180. So we know this will be 180 degrees. Subtract the sum of our two interior angles. 30 degrees plus 48 degrees. So this will be 180 degrees. Subtract 30 plus 48 will be 78 degrees. And 78 from 180 subtract 78 will give us 102 degrees. So this angle MLK is equal to 102 degrees. So this angle here. Alright? So 102 degrees. So making sure that you know your theorems and you can recognize them and use it to define what is required. Alright? So let's move on to the next part of this question. So they want us to find our angle K and M. Angle K and M. Let's see where is angle K and M. Angle K and M. So let me erase here and let's find angle K and M. So angle K, so this is part D, angle K and M. Okay? So where is that angle located? K and M. So K and M, N is your fixed point, and of course the two lines that are connected to that fixed point N will be KN and NM. So looking at this angle here. Good? So that is your angle KNM which we need to find. And that angle will be pretty straightforward to find because what we're going to do again is to use this important shape we see in that circle, which is your cyclic quadrilateral, to define angle KNM. Yeah? So this will be, I have my circle. Let me draw again the cyclic quadrilateral. So this is my cyclic quadrilateral. This is N, M, and let me connect K to N. Right, so that's a cyclic quadrilateral. And we're going to apply the theorem of a cyclic quadrilateral. Opposite interior angles of a cyclic quadrilateral are supplementary, meaning those two interior angles, when added, will give you 180. So if you know one, you can find the other. Yeah? So this is 102. That's 102 degrees. And because it's 102, I can find this angle K and M. Alright? So let me find that angle. I'm going to simply subtract 102 from 180. So angle K and M is equal to 180 degrees subtract 102 degrees. So 180 subtract 102 will give us 78 degrees. Alright? So this here is the right, so the first question from the exercise, and we want to ensure that we are clear on how to find those angles and the use of your theorems. Alright? So let's look at the next. So we have here this diagram. Alright, let me erase. We have that diagram, and they want us to find or show that the value of x in that diagram is 29.5 degrees, correct to one decimal place. They want us to show. When they ask you to show something in math, you have to show, or I don't want to say it's a proof, but they want to show that the result is 29.5 degrees. So we have to show by working that that is the case. So let us look at that diagram. Now these are questions you are going to see normally in 9 of the paper, and these questions often give students real trouble, alright? Because it will involve sine rule, cosine rule. Some of these questions may involve a bit of trigonometry, angle of elevation, angle of depression, will involve these things. So we have to know our trigonometry, we have to know that well, alright? So we want to prove and show that angle X is 29.5 degrees to one decimal place. Now, angle X falls within this triangle, HGF. You see that triangle there? HGF. So what I'm going to do is to take that triangle and remove it from the diagram. So you see it separated from the diagram. So this is from January 2024, question 9b, right? So I have this triangle. So this is my triangle. Okay, this is HGF. And this angle here is X. And we want to find that angle. So on that triangle we have some lengths, 11 meters, we have 6.9 meters, we have 5.3 meters. Alright, now this is something we need to be conscious of. This triangle, to find X, this triangle is not a right angle triangle. So because it is not a right angle triangle, you know trigonometry is out of the question. Okay? Or Pythagoras theorem, those would be applicable to a triangle that's not right angle. So, for a triangle that is not right angle, you're using two rules, the sine rule and the cosine rule. So in this case, to find angle X, when you have to find an angle in a non-right angle triangle, if all three sides are known in that non-right angle triangle, then you can use the cosine rule to help you to find that angle. Okay? So all three sides of that non-right angle triangle are known, and hence we're going to use the cosine rule to find or prove and show that the angle X is 29.5 degrees. So, using the cosine rule, and when you're using the cosine rule, the first thing you need to do is to label all sides. So, if this is capital N, the side opposite capital, well in fact capital H, this is H, looks like an N, so that's H. So the side opposite capital H will be common H. So this is common H. So let me put it in red. The side opposite the capital G will be common G. And the side opposite the capital F will be common F. So that's the first thing you do. You label the sides of the non-right angle triangle. Okay? Just using common letters opposite to the vertex. Okay? So use the common letter of the vertex, which is normally as a capital letter, so use the common letter to represent the side. Good? So after labeling, what we're going to do, the cosine rule, and you have to know your cosine rule, you see it in the formula sheet of the CSEC exam paper. Because we want to find the angle at X, we are going to begin our equation for the cosine rule with the side opposite the angle X. So the cosine rule will be the side opposite angle X will be this common GF, which is common H. So you're going to write common H squared is equal to my two other sides. This will be F squared plus G squared. This is the cosine rule I'm stating here. Subtract 2FG cos this angle at X. That there is the cosine rule. So I'm going to start the cosine rule with the side opposite the angle. I need to find H squared. This is when you're finding an angle. This is what we do. We begin with H squared. The side opposite is equal to my two other sides, F squared plus G squared minus 2FG cos the angle at X. Alright? So let's now just substitute it. So we know H is 6.9 in bracket squared. F will be 5.3 in bracket squared plus G, which is 11 in bracket squared minus 2 times 5.3 times 11 cos x. Yeah? So let's work out what is 6.9 squared. So 6.9 squared, that's what? 6.9 by 6.9, which is equal to 47.61. 5.3 squared is what? 5.3 by 5.3, which is 28.09. Plus 11 squared, 11 by 11, 121. Now, let's work out. This will be negative 2 by 5.3 by 11. So negative 2 by 5.3 by 11. That will give us what? Negative 116.6 cos x. Good? So, let's further simplify. We're going to get 47.61 is equal to 28.09 plus 121. That gives us 149.09. Minus 116.6 cos x. Alright? Now, what we're not going to do, and this is a common mistake students make, is subtract 116.6 from 149.09. I'm not doing that. Remember that your 116.6 cos x, you see this here? That is one term. So you can't subtract 116.6 from 149.09, because this entire thing is one term, alright? So what you're going to do is to get x by itself, there are a number of things we need to remove. The first thing we're going to remove is this 149.09. Alright? So to remove that, I'm going to subtract 149.09 from both sides. Or most students will just take the 149.09, bring it over on the left and change the sign. So this will be 47.61 subtract 149.09 is equal to negative 116.6 cos x. So 47.61 subtract 149.09 is equal to negative 101.49. Is equal to negative 116.6 cos x. Yeah? So what we want to do now is to first get cos x by itself. So how are we going to get cos x by itself? We have to remove that negative 116.6. So the opposite of that's negative 116.6 multiplied by cos x, and the opposite of multiplication is division. So you're going to divide negative 101.49 by negative 116.6, and when I do to one side, before we do to one side, we always do to the other, right? So I'm dividing negative 116.6, right? So I'm dividing negative 116.6 cos x by negative 116.6, and when I do to one side, I must do to the other. I divide negative 101.49 by negative 116.6, and what's going to happen? These two negative 116.6 will cancel out. They divide into each other to give 1. You're going to be left with cos x. And now let me divide. Negative 101.49 divided by 116.6. We're going to get 0.8704. I take about 4 to 5 places after the point, right? So we're going to get 0.8704. And therefore to get x by itself now, which is what we want to find. This angle x here, this angle x here. To get x by itself, I need to remove cos, which will come across to the left as cos inverse. So this will be cos inverse of 0.8704 is equal to x. So let's find cos inverse of that, and that will help us to determine angle x. So, and let's see if it's 29.5. Let's see if we go together. So shift cos 0.8704. Yep. So to one decimal place, that is what? 29.49 degrees. And to one decimal place, we count one place after the point, which is a 4. We look at the number after, which is 9. Once it's 5 or more than 5, we add 1 to our 4 to become 5. So this is 29.5 degrees. So we have shown that, and that's what they ask us to do, to show it. And because they ask you to show, and you have shown it, you write at the end, and hence shown. Alright? So remember, when it comes to finding an angle in a non-right angle triangle, once or if all three sides are given, you have the lengths of all three sides, one time you're going to use the cosine rule to help you to find that angle in that non-right angle triangle. Alright? So let's look at the next part of this question. Next part says what? Right, so we have shown that. Right, so it says now, a vertical tower GT is constructed at the point G, and it is pivoted to the ground at the points E, F, G, and H using pieces of wire. Right? So you have this vertical tower GT, and it is constructed at the point G, and it is pivoted to the ground. So it's going to be pivoted to the ground at the points E, F, G, and H. So if it's pivoted, it can't move, right? Pivoted, stuck to the ground there. The angle of elevation of the top of the tower T from the point F is 31 degrees. What length of wire was used to secure point T to point F? So let's go back to that diagram. So make sure you're familiar with this type of question and this part of the question. So let me raise this here. So it says here what? It says, let's read the question and make sure we're clear on what they're asking, right? What information is given. E, F, G, and H are 4 points on a level ground. Let's make sure you understand what is a level ground. Level ground is a ground that you're all standing on presently. So you're home in your house, you stand up, get off your chair, you stand up, you're on level ground, right? So the ground we're all standing on presently. And I am on level ground, and if I'm standing on level ground, I am vertical. Level ground is always considered to be horizontal. So this is level ground here. And if this is me standing here, right? So level ground is horizontal, and me standing on level ground, I will be what? Vertical. And once you have a vertical meeting that horizontal, they're going to meet at what? Right angles to each other. Alright? So, when you talk about level ground, it says E, F, G, and H, they are level ground, so flat ground. But it states here that a vertical tower GT is constructed at the point G and pivoted to the ground at the points E, F, and H using a piece of wire. So we'll have this vertical tower, right? And it's going to be, let me draw that vertical tower. Let's assume that that's our vertical tower. So you have your vertical tower. GT is constructed at the point G and it is pivoted to the ground at E, F, G, and H. So the vertical tower, GT, which is vertical upright, so these are all flat on the ground. You have a vertical tower sticking up, right? Vertical. And it's going to be pivoted by H, F, and E. So H, F, and E is holding that vertical tower in place. Good? So all flat on the ground. What they want us to do is to right, it says the angle of elevation at the top of the tower T from the point F is 31 degrees. So the angle of elevation, so this is what we're looking at here. So the angle of elevation, what is the angle of elevation? If you're standing somewhere, you're going somewhere, and you're going a merry way, you're walking, you will initially have what? A horizontal line of sight. You'll be looking forward. And if someone calls out to you, your horizontal line of sight will change to an upward line of sight. So you look up. So the angle between your horizontal line of sight and upward line of sight, that angle between those two lines of sight will be your angle of elevation. So the angle of elevation, looking up. So we want it says the angle of elevation from F to the top of the tower T. The angle of elevation is what? You see, it says it's 31 degrees, right? So the angle of elevation of the top of the tower T from the point F is 31 degrees. This is 31 degrees here. Good? And remember, G, F, H, and E are all on level ground, flat ground, not so? And if they're all on flat ground and GT is sticking out, remember GT, that tower is pivoted, held together by E, F, G, and H, and if it's sticking out and everything else is on flat ground, then this angle between G, T, the tower, and G, F is 90 degrees. Okay? Because remember, a vertical always meets a horizontal at right angles. So this is what we're looking at here. We are going to have G. So let me take out that diagram and place it on the board, this side of the board. I'll have G, T, which is my vertical tower. I will have G, F, which is on a level ground, and level ground is always represented as a horizontal line. Yeah? And the angle between GT and GF is 90 degrees. And the angle of elevation from the top of the tower T, from F to the top of the tower T, from F to the top of the tower T, that angle of elevation is what? 31 degrees. Good? And the distance from G to F is 6.9 meters. Alright? So the length of that line GF is 6.9 meters. What the question wants us to do is to find, to pull out that right angle triangle, what is the length of wire used to secure point P to point F? What length of wire is used to secure point, did I say P? Let me see. Point T to point F. Good? Point T to point F. What length of wire is used to secure point T to point F? So we have to find this length. Yeah? And this is where your knowledge of trigonometry will come into play. Sine, cos, tan, using a right angle triangle only. So remember, you're going to use SOHCAHTOA. Right? Remember, sine theta is opposite all over hypotenuse. Remember, cos theta, sine adjacent over hypotenuse. Remember, TOA, tan theta, side opposite all over side adjacent. Alright? So, which of those three we're going to use to help us to find this length from theta f? So, in a right angle triangle, yeah, in a right angle triangle, when you are given an acute angle and you have a side, then automatically we're going to use trigonometry. We can't use Pythagoras term here because we do not have information for two sides to help us to find the third. Alright, we have the information for one side and we also have an acute angle, so one time trigonometry should come to your mind, right? So using trigonometry, you know, the first thing we're going to do is to label our sides. The side opposite the right angle is the hypotenuse. The side opposite the acute angle, 31 degrees, will be side opposite. And the remaining side will be the side adjacent. Yeah? So, how do you know which of the three trig functions we're going to use to help us to find, you know, the length? So, we always, and I always advise students, you circle the side that you have to find. You have to find TF. So you circle that side, which is hypotenuse. You circle the side you have to find. And you circle the side you have information for. You have the length for. You have the length for the adjacent side. Yeah? So what trig function is the two that I've circled? Two sides I've circled. Adjacent and hypotenuse. That's what? Cos theta. So I'm going to write here cos theta is equal to side adjacent all over the hypotenuse. I'm going to replace theta with 31 degrees. Cos 31 degrees is equal to my side adjacent, which is 6.9. over the hypotenuse, which is TF or FT. And this is an equation. Cos 31 is equal to 6.9 over TF is an equation where a fraction is involved. And you never solve an equation with fractions. You always want to remove the fraction from the equation so you can solve it comfortably. So, how are we going to remove this fraction? Because cos 31, I can put cos 31 over 1. I have one fraction on the left of the equal sign. I have one fraction on the right of the equal sign. And when you have one fraction on the left, one fraction on the right, to remove it from the fraction form, you can cross multiply. Yeah? Or you can multiply both sides by TF, anyone you want to do. Yeah? If you multiply the side by TF, you multiply that side by TF, we can remove the fraction. Okay? But I'll carry on the cross multiplication approach. So I'm going to multiply TF by cos 31. And I'm going to multiply 1 by 6.9. Alright? But our aim is to get TF by itself. Right? You want to get TF by itself. So to get TF by itself, it means you have to remove cos 31. So how am I going to remove cos 31? Remember, this is TF multiplied by cos 31. The multiplication sign, it's not seen, but it is understood. And the opposite of multiplication is division. So to get TF by itself, I'm going to divide what is on the left by cos 31. And what I do to one side, I do to the other. I divide 6.9 by cos 31. So when the two cos 31s divide into each other, to give you 1, and you have TF by itself, then we can get our final answer by dividing 6.9 divided by cos 31, and we're going to get 8.049. 8.049. That's what meters, yeah? They ask to approximate anything, let's see. Alright, they didn't ask us to approximate, right? to any number of decimal places or significant figures. So, if you want, we can put the answer to 2 decimal places, right? So I'll count 2 places after the point. 1, 2. I look at the number immediately after, which is 9. Once the number immediately after is 5 or more than 5, I'll add 1 to my 4 to become 8.05 meters to 2 dp. And make sure you tell your examiner how many decimal places you approximated the number to. Alright? So make sure that is stated. Alright, so this here is that part of the question. Alright, so we have some other parts of this question. So, the bearing of E, so a bit of bearings now is in this question, and of course, we want to make sure we understand our bearings, because I'm certainly going to see bearings on Monday. I'm certainly going to see circle theorems. I'm sure you're going to see something with sine, cosine rules, so you want to make sure you understand everything in relation to that, right? So the bearing of E from H is 228 degrees. Find the bearing of H from E. So the bearing of E from H is 228 degrees. Find the bearing of H from E. So let's go back to that diagram. Right? The bearing of E from H. Let me write that down so on the board, so I have it directly in front of me. So I'm going to erase that right angle triangle, take out all this information, and let's look at that part of the question. So what's what we're going to have here? This will be what? This will be, so I'm going to write it down here. So the bearings of part 3 of this question, right? The bearing of E from H is 228 degrees. So the bearing of E from H is 228 degrees. Find the bearing, find part A, find the bearing of H from E. Alright? So the bearing of E from H is 228 degrees. Now let's make sure we understand when we talk about bearing. What is a bearing, right? The bearing of E from H. E from H. Remember, bearing is an angle. Just keep in mind when you talk about a bearing, it is an angle, and what it does, it shows the position of one object relative to another. And with a bearing, if I say the bearing of P from Q is say 210 degrees. Good? Bearing of P from Q is 210 degrees. P from Q. So I want to determine where is P's position from Q's position. Right? So what you do, you put Q's position on the board first, because you want P from Q, from Q. Always with bearings, you set up a north line. Alright? So you have your north line. And what you're going to do, and I'll put a nice little dotted from a south, east, and west. So you at least have some cardinal direction. So south, east, west, the cardinal points there, north, south, east, west. And with your bearing, you always move in a clockwise direction from the north line. So bearing is an angle, right? So let me show the angle here. So we can locate where is P's position from Q. The bearing is 210. So I'm moving. This is what? 90. That's why I have the north, south, east, west. 90, 180, and 210 might be somewhere around here. So this is me moving from Q to P. So I've located P's position from Q, a bearing of 210 degrees. So that's what a bearing will do. It will help you to locate the position of one object relative to another, but to show your bearing, you must set up the north line and move in a clockwise direction from the north. So let's see. We say here, from the question, the bearing of E from H. E from H is 228 degrees. E from H. So this is E here from H. So from H, you set up your north line, which is already there. You already have a north line there for you. And what you're going to do now is move in a clockwise direction from the north line to that line connected E to H. Alright, so on E from H, this line here. So from your north line, you move in what direction? Clockwise direction. So you see that angle? That bearing is your 228 degrees. That is stated there. That's your 228. Alright, this is your 228. That's your bearing, okay? Of E from H. But they want us now to find the bearing of H from E. What's the bearing of H from E? So from E, you're going to set up a north line, which you already have there. And let me make that north line a bit higher. And I want the bearing of H from E. So you already have the line connecting H to E. And from that north line, you move in a clockwise direction. From the north, no other direction, only clockwise to the line connecting H and E. Good? So that is the bearing we need to find. Okay? That is the bearing of H from there. We need to find that angle. So how are we going to find that angle? So one thing with bearings, you always see this coming into play with bearings, and you need to know these angles for other questions, because you'll see these angles I'm going to place on the board coming into play with sometimes you see it in circle theorems too. Of course, you'll see it in bearings. It will bring questions involving angles, you know. So when you're dealing with two parallel lines, there's some important angles that always come into play. So when lines are parallel, two lines that are parallel, moving in the same direction, like these two north lines here, those are two parallel lines. And when I have a line drawn connecting those two parallel lines, which we call a transversal line, what's going to happen here? Some angles will be created. You see a Z shape here? Z shape, like so, right? Then this angle here will be equal to this angle here. And that angle will be said to be alternate. So it's an alternate, not alternative. Right? Students say all kind of thing. Alternative. That's alternate angles, right? And you'll have again two parallel lines, transversal drawn, and you have that F-shaped form when this angle is equal to this angle. That will be called corresponding angles. And then you have, again, two parallel lines, which is like this too. Where this angle and that angle, when we add, those are called two interior angles. This angle, call it A, call that one B. When you add them, you'll get 180 degrees. That angle there is said to be co-interior, call it co-interior angles. So you see these three angles, pay close attention and make sure you know these three angles. This is co-interior angles. Alright? So to help us find this angle here, which is the bearing of H from E, this angle here, one of these or more than one can be used to help us to find it, alright? But The simplest one is this. Co-interior. You're seeing two north lines here. Two north lines are two parallel lines. Good? This is a transversal from H to E. This line drawn here is a transversal. Alright? And you'll see here you have your box shape. Look at the box shape here. Bap, bap, bap. See the box shape? That's a box shape there. So let me power the box shape here. You have this here. So this was in north. This is the north. This is H. This is E. This is north. Alright? You have the two parallel lines. You want to find this angle here, which is the bearing of E of H from E, right? But to help us to find that, we need to get this angle here. If I find this angle here, then I can use co-interior angles to find this angle which represents the bearing of H from E. So how am I going to get this angle here is important. So to get that angle, this is what we're going to do. We clearly see that this entire angle here is 228. And if I need to find this angle here, which is this angle, we need to find that angle. This is a full circle. Yeah? And you know a circle will be equal to 360 degrees. So I can determine that angle here, which is NHE. NHE. Yeah? Or EHN. I can find that angle by subtracting 228 from 360, which is 132 degrees. Yeah? And if this is 132 degrees, then I can find the bearing of H from E by subtracting 132 from 180 to give us 48 degrees. Alright? So we're going to say here, just to, to put a nice little statement when you're doing these questions, to show how you got your answer. So you're going to tell your examiner when you're doing the question that angle NHE, so this is the solution here, angle NHE, the little symbol on top of the H means angle, angle NHE is equal to 360 subtract 228, which is 132 degrees. And therefore, the bearing of H from E will be equal to 180 subtract 132, which is 48 degrees. And if you give the reason to tell them where you got it. That's 48 because of what? Co-interior angles. Alright? Yeah? So, that part of the question when they ask us the bearing of E from H is 228, find the bearing of H from E. So that's how we found the bearing of H from E. And now let's we have the other part of the question. Find the bearing of G from H. So part B. You know what is to find part B, the bearing of G from H. Good? And let me just write on top here the topics we're doing tonight, right? So remember it's circle theorems. And bearings, right? Make sure we can answer those questions well. Do that in the latter part of the paper. Bearings, the circle theorems, your matrices, your vectors, your transformations, answer that well. You'll be in a good position to pass. Alright? Because these topics, these questions often give students some trouble. So, Let's look at now the other part of this question. What is the bearing of G from H? The bearing of G from H. G from H. So I'm going to erase this. So you want G, let me go back to the diagram. Right, you want the bearing of G from H. G from H. So where is G and where is H? This is G and H here, right? So you want the bearing of G from H. So this is what we're looking at. The bearing of G from H. So from H, we set up our knot, which is already there. And it would move in a clockwise direction to the line connecting G and H. There's a line connecting G and H here. So from your north line, we move in a clockwise direction. So you see that bearing there? This angle here? I want to find that angle. That's the bearing of G from H. So we're going to find the bearing of G from H. So to find the bearing of G from H, pretty straightforward. You know that this entire angle here is 228. Alright? They told us that before. So the bearing of E from H is 228. Good? Part of that 228 is 54. 54 occupies here. Alright? So if you subtract 54 from 228, you're going to be left with this angle here, which is the bearing of G from H. Yeah? So this entire angle here is 228. And all I have to do is to subtract 54 from your 228 to give me this remaining angle, which is the bearing of G from H. So for that part of the question, we're going to write here, so the solution, so the bearing of G from H will be equal to what? That's simply 228 minus 54. What's 228 subtract 54? That's the first one. 228 subtract 54 by 174 degrees. Alright? And that's the bearing of G from H. Alright? So make sure, class, that we understand the bearings. We can handle those bearings question well, right? We're going to be doing some more tonight. So, right, so let's move on to another circle theorem question. And we'll do some more bearings as well, right? Let's make sure we have a solid understanding of our circle theorems and our bearings. So, let's look at the circle theorem question. LMN, this is from June 2023, right? LMN are a point on the circumference of a circle. So, L, M, N, and R. Points on the circle. Upon the time I look at that, I'm seeing something should stand out one time. When you look at it, I see it standing out. Two things, in fact, we just did in the question before. I see standing out one time in this question. Alright? So L, M, N, and R. I want you all to think about it. What are the two? What are the two that stands out? L, M, N, and R are points on the circumference of a circle with center O. PQ is a tangent to the circle at R. So remember what's a tangent? A line drawn to touch the circumference of the circle. And there are some important laws that are applicable to a tangent drawn to the circle, right? Angle PRL is 48 degrees. So we know where is PRL. R is a fixed point that's in the middle, so you know it's going to be located at R between the two lines PR and LR or RL. Good? So this is the angle 48 degrees. Angle RON is 156 degrees. So you know O is a fixed point, and of course you're going to have the two lines ON and OR, right? 156 degrees. So what I see standing out one time when I look at this diagram with two things. I see an isosceles triangle here, back. Hope you all see that. Two radii. Both N is a radius, both R is a radius, and therefore those two sides are equal, and this triangle is isosceles. These two sides here are equal, and therefore that's an isosceles triangle. I also see what stands out one time. Cyclic quadrilateral, LMLR. See that cyclic quadrilateral there? So that theorem of the cyclic quadrilateral, or theorems of the cyclic quadrilateral, there are two, can come into play here to help you. Alright? So let's see. Right. Find the value of each of the following angles given reason for each of your answers. Show all working where appropriate. So they want us to find the angle R. So you want to find the angle at R, this angle here. Good? And what theorem can we use there to find the angle at R? And again, it requires you to know your theorems, alright? You have to know your theorems and recognize what theorem can be used to help you. Alright? So one time I am seeing a theorem that we used in the previous question. And that's this theorem here. So let's look at it. I'm going to pull out the theorem so you can see it, right? How is that applicable? So let's take out the term that is applicable to find R. So this is my center. This is R, that's N. Good? This angle here is 156. Right? Look at the term. This is the term. This arc drawn from N to R, it subtends this angle at the center. Remember what the word subtend means, right? It created that angle at the center, 156. This arc length. So a line drawn from N to the center, from R to the center, it creates this angle 156 degrees. That arc length allows that to happen. Now this same arc length, see that same arc length from N to R, look at what it's going to do too. It's going to create this angle here at the circumference. Good? So the arc length creates the angle at the center, 156, and that arc length N to R also creates this angle at the circumference. And you have to know that term, which states the angle at the center of the circle is always twice the angle at the circumference, subtended by the same arc. So you see that angle at the circumference there, that R, this R is what you want to find here, this R. R there will be 156 divided by 2. Which will give you 78 degrees. So R will be 78 degrees. Alright? So let's make sure we write it down properly, because it says give reasons, right, for each of your answers. So you have to know your reasons, right? So the reason will be the fact that angle R is equal to 156 divided by 2, which is 78 degrees. And the reason will be the angle at the center of the circle is twice the angle at the circumference subtended by the same arc. Okay? So that there is your theorem to find out. Good? Alright, let's see. What does it ask you to find? Find angle E. Let's find angle E. Angle E. Where's angle E on that diagram? Angle E is here. Right. Alright, you see angle E? So you want to find that angle E. So we're going to find that angle E. So I'll pull out the term that will be used to help us to find the angle at E. So let me erase this. So look at the term we're going to use to find the angle at E. Yeah? The term is this. If we look carefully, and this is, and again we use this term in the question we did previously too. Look at it here. Circle. Right? This is a tangent. See my tangent? This is a chord. This is a chord. Alright? This is an angle between your chord and your tangent. So this is your chord and this is your tangent. So an angle is formed between your chord and your tangent, which is E. Good? So this angle between the chord and the tangent is always equal to, this is a very common term, always equal to the angle that the chord subtends at the circumference. So if we look here, the angle between this chord and this tangent is equal to the angle. Look at it, the chord is going to subtend. So a line drawn from N, R, well, this is Q, this is P, that's a tangent. So a line drawn from N to the circumference, from R to the circumference, they both meet here at L, which is this angle common R, which we just formed. Alright, we just found common R to be what? 78 degrees. So if this angle is 78 degrees, then we expect the angle at E to also be 78 degrees. So E will be 78 because of that term. The angle between the chord and the tangent is equal to the angle the chord subtends at the circumference, creates that angle at the circumference. Yeah? And let's see if they ask us to, right, they wanted to give a reason, right, for all of those. So let's give, so we're going to state your angle E is 78 degrees. And what's the reason? You're going to state the angle between the chord and the tangent is equal to the angle the chord subtends at the circumference. Of the circle. Good? So that angle at E, this angle R is 78. This angle at E will also be 78 degrees. Alright? Alright, let's see what the other part of this question asks us to find. They wanted to find the angle A. The angle A. Where's the angle A? This is the angle A here. That. Good? So to find A, what we're going to do, this is where your cyclic quadrilateral will come into play. We've seen that cyclic quadrilateral, it didn't give you that. Right? Just so they give you it for a reason. Right? And what is the reason? So I'm going to erase. So look at it. I'm going to draw the circle, the cyclic quadrilateral. It will show how we're going to get A. Right? So this is it here. Circle. Let's draw cyclic quadrilateral. Right? Cyclic quadrilateral, we have R, N, M, L. Alright, this is A. So I want to find A. Alright? So to find A, this is what we're going to do. We can find this angle here. See this angle here? You can find that angle there within the cyclic quadrilateral, because you know this is 78, you know that is 48, you know this is a straight line, hence that's a straight angle 180 degrees. So you can add 78 to 48 and subtract from 180. 78 plus 48, 126 from 180. So this angle inside here will be 54. So this angle here is 54 degrees. So this angle here is 54 degrees. Good? And therefore we can find A by using that important term. Opposite interior angles of a cyclic quadrilateral are supplementary. Yeah? So you can easily find A. So A will be equal to 180 degrees, subtract 54, and 180 subtract 54 will give us what? 126 degrees, and it'll give you a reason. You should know your reasons, right? You should know which is opposite interior angles of a cyclic quadrilateral are supplementary. And remember what supplementary means, right? They must add to give 180. Alright? So that is us finding A, R, and E. So A is 126. Good? Alright? So let's see. Okay, so let's look at this other question here, which is again a question which will involve, you know, your rule, sine rule, cosine rule, my trainer bearings there, right? So let's make sure we clear on this. Right. So again, we're going to pass it for June 2023, right? Question 9b. So the diagram below shows a triangular field. Horizontal ground. Remember what's horizontal ground, eh? That's the ground you're standing on. So get off your chair, get off your chair now and stand on that ground. Bam. That's horizontal ground, right? Yeah? So that's flat on the ground. So think of that flat on the ground. Good? And, yes, it's on horizontal ground. And it states here, calculate the value of angle MLP. So they want to find the value of angle MLP. So part 1, find angle MLP. Now let's make sure we know where that angle is located. Again, letter in the middle, that will be a fixed point between two lines ML and PL. Good? So letter in the middle L between two lines ML and PL. So this is your angle here. Good? You want to find that angle. Next step, you tell yourself that angle falls within a triangle. So you look at the triangle. That triangle clearly is not a right angle triangle. So it is a non-right angle triangle. And when you look at that non-right angle triangle, what we observe? We have information for 3 sides. Blah, blah, blah. You have no other angles inside there, right? But you have all 3 sides. So if you have to find this angle, let me just name it, let me call it x. If I have to find x there, I know I'm going to use what rule? My cosine rule. Alright, so you're going to use the cosine rule to find that angle x. Okay? So, using the cosine rule, so angle MLP, which is also equal to x, right? That's what equal to x. Good? We're using the cosine rule. So the first thing you must always do is to label the side. So the side opposite capital L is common L. The side opposite capital M is common M. The side opposite capital P is common P. Good? And how are we going to form that formula for the cosine rule? We want to find this angle at x. So always begin with the side opposite the angle x. So the side opposite the angle x will be that common L. So you're going to write common L squared is equal to the other 2 sides. P squared plus M squared minus 2pm cos the angle at x. Alright? And what you do now is substitute into your formula. You're going to replace L with 180 in bracket squared is equal to P squared 120 in bracket squared plus M 150 in bracket squared minus 2 times 120 times 150 cos x. Remember you want to find x, right? So you want to find x. So everything else you have to make sure everything else is replaced with some number. Alright? So let's work out what is 180 squared. 180 squared, that's 180 by 180. That's 32,400. Is equal to what's 120 squared? That's 120 by 120, which is 14,400. Plus 150 squared, that's 150 by 150, which is 22,500. Right, let's work on negative 2 by 120 by 150. Negative 2 by 120 by 150, that is negative 36,000 cos x. Good? So, the aim is to find x, right? So let us further simplify. This is 32,400 is equal to 14,400 plus 22,500, 36,900. Subtract 36,000 cos x. Please don't subtract 36,000 from 36,900. Remember, this is one term here. So you can't subtract 36,000 from 36,900, alright? So, what are we going to do to help us get x by itself? The first thing you have to do is to remove this 36,900 by moving it from the right to the left, change the sign. It's equal to minus 36,000 cos x. 32,400 subtract 36,900 will give us negative 4,500 is equal to negative 36,000 cos x. See how we're working out to get x? Everything breaking down piece by piece. So, to get cos x by itself, you have to remove negative 36,000. This is negative 36,000 multiplied by cos x. So the opposite of multiplication is what? Division. So it's negative 36,000 cos x divided by, so you have to divide because the opposite of multiplication is division. So divided by negative 36,000, and what you do to one side, you're going to do to the other. So negative 4,500 divided by negative 36,000. So your two negative 36,000 will divide into each other to give you 1. You're left with cos x and negative 4,500 divided by negative 36,000 will give you 0.125. And therefore, to get x by itself, that angle, so we break down everything using a rule to get x as a subject. To get x by itself, we're going to remove cos, which will come across on the other side as cos inverse of 0.125 is equal to x. And what is cos inverse of 0.125? Second function cos bracket 0.125 close brackets. You're going to get 82.8 degrees is equal to x. And let me put it to one decimal place, right? 82.81 degrees, and to one decimal place 82.8 degrees. Right? Because we count one position after the point, we look at the number immediately after, which is 1, it's less than 5, so your 8 stays as is. So the angle at x is 82.8 degrees. Good? So using the cosine rule, so get familiar, make sure you know your cosine rule to find an angle. You can also use it to find a side, and we'll do a question where you use it to find a side, right? So to find an angle using the cosine rule, you must have information for all three sides of that triangle, okay? Yeah? And we'll do an example where we have to use it as well to find a side. So we've got a few more questions, right? So let's look at next part. Calculate the value of angle M. Well, that's what we just did. Then what is the, right? So the other part 2. The bearing of P from L is 210 degrees. Find the bearing of, I see the bringing bearings, I love to bring in bearings. So you know they're going to bring in our bearings and tip, right? So let's make sure we can deal with the bearings part of this question. So I'm erasing this information. Right, so the bearing of P from L is 210 degrees. Let me put part 2. The bearing of P from L is 210 degrees. Okay? Find the bearing of M from L. They want us to find the bearing of M from L, right? So let's look at that. So going back to your diagram. So it says here the bearing of P from L. P from L is 210 degrees, right? P from L. So you know from L, and when it's a bearing is an angle, and you must set up a north line. And you must move in a clockwise direction. Don't forget that. So P from L. So from L, we have the north line already set up. And we're going to move in what direction? A clockwise direction from the north line to the line connecting your P and L. Good? So this is your bearing. That is the bearing of P from L. Okay? That entire angle. Okay? So we want to find, so they told us that the bearing of P from L is 210. So we know that bearing, that angle I've drawn in red there, is 210 degrees. Alright, so make sure we know what is the bearing of P from L, 210. So you have that 210 degrees. Find the bearing of M from L. Find the bearing of M from L. M from L. So from L, I set up my north line, which I already have. I'm going to move in what direction? Clockwise direction from the north. So I'm looking at this here. Let me put it in black. Clockwise direction from the north to the line connecting what? To the line connecting M and L. Okay? So I want to find that bearing. So from my north line, I'm moving in a clockwise direction to the line connecting M and L. So how am I going to find that angle? How am I going to find that bearing? And look how easy. You know this entire angle here is 210. You know, part of that angle is what? 82.8. So what you have to do is to subtract 82 from 8 from 210, and you'll be left with that angle, which is the bearing of M from L. Good? So the bearing of M from L is straightforward. That will be equal to 210 subtract 82.8 degrees. And let's subtract those two. 210 subtract 82.8. 127.2 degrees. Alright? That's the bearing of M from L. Let's look at the other part of that question. Right, so calculate the value of angle NLP and hence find the bearing of L from P. So they want us to have part B. They want us to calculate the value of angle. So what is to calculate angle NLP and hence find the bearing. Hence find the bearing. Find the bearing of L from P. Alright, so let's look at that. So we go back to the diagram. Right. So they want us to calculate angle NLP. Where is that angle? NLP. So where is angle NLP? L is your fixed point. And it will occur between two lines. This is L, the fixed point. It occurs between two lines, NL and LP. So this is your angle NLP here. That dotted line I have there, that is angle N. That dotted arc I have there, that is angle NLP. So you want to find that angle. So we're going to find that angle. That should be straightforward. This is a full circle here. Back. Full circle. You already know this is what? 210. So that solid arc there, solid bearing angle is 210. So what you have to do is to subtract 210 from 360 and you're able to find angle NLP. Yeah? So angle NLP will be equal to, that will be equal to 360 subtract 210, and we know 210 from 360 will give us what? 360 minus 210, that's 150, right? So this is 150 degrees. Angle NLP. So it's always important to know where the angle is located. So this is 150 here. Okay? Then they ask us to find the bearing of L from P. What is the bearing of L from P? So bearing of L from P. So from P, where is P? This is L, right? So I want L from P. So from P, I'm going to set up my north line. Remember, once you want to find a bearing, you must set up that north line. And you must move in what direction? Always a clockwise direction from the north line to the line connecting your L and P. So that is the bearing we need to find. And that should be straightforward. Because what comes into play? You have your two north lines. The two parallel lines, not so? And what angles will come into play? Two parallel lines. This is a transversal. What we see here, the box shape, co-interior angles. You all see that box shape there? So therefore, to find the bearing of L from P, this is what we're looking at. So put out this here. NLP. This is already 150. And I need to find this angle here. So, co-interior angles. Make sure you know your angles for lines that are parallel to each other. Co-interior angles. So therefore, the bearing of L from P is equal to what? That's what? 180 subtract 150. So we get what? 30 degrees, and I'll put for co-interior angles. Alright? So that's finding the bearing of L from P. So this is 30 degrees here. Alright? So, see a bearings question. You want to use it, you know? You want to use that bearings question. Alright, so what I will do, so let me erase this. Right, what I want to do is to look at, let me see what this question is all about. Right, circle theorems, circle theorems. Circle theorems. I think I want to do the circle theorem question here. Right, let's do another bearings. Let's look at another bearings, right? Because I want to do a bearings question where you have to use the cosine rule to find the length of a side. And I also want to do a bearings question where the sine rule comes into play, right? So I want us to see where the sine rule can come into play, right? Yeah, so let's look at this question. Okay, so just give me 2 seconds. Alright, so let's look at this bearings question, right? So, it says here, from a port L, ship R, so from a port L, so you're sure we're going to see a bearings question on Monday, so let's make sure we understand bearings well, right? So from a port L, ship R is 250 kilometers on a bearing of 65 degrees. Ship T is 180 kilometers, which we see from L on a bearing of 148 degrees. This information is illustrated in the diagram below. So we see the distances, right? From R from L is 250, T from L is 180. Good? But what we need to do, which I'm sure we'll have to do in this question, is to show the bearings on the diagram. It's a bearings question, so you know you have to show those bearings they gave us there on the diagram, alright? So they want us to complete the diagram above by inserting the value of angle RLT. So where is angle RLT? So they want us to complete the diagram by inserting the value of angle RLT. So we have to find angle RLT, right? So let's look at part one. They want us to find angle RLT. Right? We already have the word angle there, so I have to put the symbol above the L. Good? So the first thing I want to do is, alright, let us include in our diagram because they gave us some bearings. So we can't ignore that. So to help us to find angle RLT and where is that angle located, again, L is at the middle fixed point, and that will occur between two lines, RL and LT. So where is RL? RL is here, and this is LT or T, right? So this is your angle you need to find. But you need to find that angle. But to find that angle, they gave us some bearings. So let's make sure we place those bearings on the diagram as well, which I'm sure will help us in some way. So, from a port L, ship R is 250 kilometers on a bearing of 65 degrees. So ship R is on a bearing of 65 degrees from L. So let's show that bearing or angle of 65 degrees. So from L, I set up my north, which we already have the north. I'm going to make it a little higher. We already have that north line. And we always move in one direction. We move in a clockwise direction from the north. And this is what? It's the bearing of what? Of R from L. So we're going to draw from the north line in a clockwise direction to the line connecting R and L. So this is what we're looking at here. Right? To the line connecting R and L. So that there will represent your bearing of 65 degrees. Alright? So between your north line and your line RL, that's 65 degrees, your bearing of 65 degrees. Ship T is 180 kilometers, which we see from L on a bearing of 148 degrees. 148 degrees, let's show that on the diagram. Are we going to show 148 degrees? So again, from my north line, and again this is ship T from L. From L. So from L, I set up my north line, which I already have, and I'm going to move in what direction? I'm going to move in a clockwise direction from the north line to my line connecting T to L. Alright? Because it's stated here, ship T is 180 kilometers from L on a bearing of 148 degrees. So T from L. So you're drawing that arc representing your bearing or angle from the north line to the line connecting T to L. And this here is what? This is 148 degrees. So with those two bearings included, don't you think it's easy now to find angle RLT? Would it be easy to get this angle here? Yeah? That angle will be easy to find now because all I have to do is to subtract 65 from 148. Yeah? So I'm subtracting 65 from 148 to give me that angle there. RLT. So angle RLT will be equal to 148 subtract 65 degrees. And what's 148 subtract 55? Let's work that out. 148 subtract 65, 83 degrees. So this angle here is 83 degrees. Alright, making sure we know how to find that. 83 degrees. And let's see the other part of this question. Right. Calculate RT, the distance between the two ships. Very important, right? So they want us to find the distance between the two ships. The two ships are what? Ship R and ship T. We want to get the distance between those two ships. So we can have part 2 of this question here. So they get the distance between the two ships. So they get the distance between the two ships. This is where again your cosine rule will be used. You're going to use your cosine rule here to help you to get the distance between two ships. Why the cosine rule? Because the cosine rule is also used to find the length of a side of a non-right angle triangle. We looked at 2 examples previously where the cosine rule was used to find the size of an unknown angle, and that was used provided all 3 lengths of that non-right angle triangle were given. In this case, we have a non-right angle triangle. This RLT is a non-right angle triangle, and we want to find RT. But we are going to use the cosine rule to find the length of RT. And I'm going to show you why using the cosine rule. Because when you have a non-right angle triangle, and I love to bring this with your bearings question. This is R, this is T, this is L. Once you have information for 2 sides, this is 250 kilometers, this is 180 kilometers. This is an included angle, 83 degrees. So, when you are given a non-right angle triangle, you have to find the length of a side. When you look opposite to that side, you need to find. Look opposite. What do you see? 2 known sides and an included angle. This angle between those 2 known sides, they meet at L. Good? The 2 known sides meet at L. And this angle between them, it's called an included angle. If you have a triangle like this, suppose this was a 250 here, and this was 180 here, and if the angle was here, suppose the 83 was here. This is not an included angle. Right? The included angle will occur, right, between your 2 known sides must meet at a common point, and the included angle, of course, will occur between those 2 known sides and your fixed point. Yeah? So this is your included angle. This is not included because, yes, we have 2 sides, but of course the included angle must occur between your 2 known sides and your fixed point. Alright? So this is not an included angle. Alright? Even though we have 2 known sides and an angle, this is not included. So this will be our included angle. And of course, because of recognizing that, we can use the cosine rule to find the length of RT. So this distance here from R to T, we can use the cosine rule to help us to find that. Okay? So let's use the cosine rule. And using the cosine rule, we are going to label our sides first. Also remember to label your sides. So if this is capital L, the side opposite capital L will be common L. If this is capital T, the side opposite capital T will be common T. If this is capital R, the side opposite capital R will be common R. So always label using common letters, right? Which will be opposite the vertex, which is normally a capital letter. So these are called vertices, right? So let's create our equation for the cosine rule. So we want to find side L. So you're going to begin with side common L, which is the same RT. So RT is common L. So you begin with using the cosine rule. And with the right here, common L squared, right? That's the side you need to find, is equal to my two lone sides, which will be t squared plus r squared, or you can write r squared plus t squared, it doesn't matter the order, minus 2tr cos the included angle. That's the included angle, and I'll mark that as L. That is the cosine rule, and we're going to use that to help us to find the unknown side RT. Alright, and recognize, because when we look opposite RT, we see two known sides and an included angle. Alright, so we know one time cosine rule. So let's work it out. L squared is equal to, I'm replacing t with let me use this. I'm replacing common t with 250 in bracket squared plus, I'm replacing common r with 180 in bracket squared, subtract 2 times 250 times 180 cos the angle at L, which we know is what? 83 degrees. That's your included angle. Alright? Using the cosine rule, making sure you recognize when it has to be used, and therefore let's simplify so we can find common L, which is also RT. So L squared is equal to, let's work out what is 250 squared. That's 250 by 250, which is 62,500, plus 180 squared. That's 180 by 180, which is 32,400. And we have negative 2 times 250 times 180 will give us negative 90,000 cos 83. So let's work out what is, go to your calculator, make sure it's in degrees, and let's find cos 83. So press cos 83 equals, and I'm going to put in brackets 0.1218. And you can take about 4 to 5 places after the decimal point, because it will often help you to get a better approximation to your answer, right? So don't put 0.12. Make sure you have about 4 to 5 places after the point, alright? So let's simplify. We're going to get L squared is equal to 62,500 plus 32,400 will give us 94,900. Then minus 90,000 times 0.1218. Now what you're not going to do is subtract 90,000 from 94,900. That's a common mistake students make. Remember, 90,000 and your 0.1218 is 12. That 2 TR cos L is 12. Alright? So please don't subtract 90,000 from 94,900. So this will be L squared is equal to 94,900, and now let's multiply negative 90,000 by 0.128, and let's see what we're going to get there. Negative 90,000 multiplied by 0.1218. Negative 10,962. Yeah? So, negative 90,000 multiplied by 0.1218. Right? So negative 10,962. So let's subtract those two now and make L the subject. So we're going to get here now. L squared is equal to 94,900 subtract 10,962 will give us 83,938. And if we have to get L by itself now, this power of 2 must go. So to remove a power of 2, what we're going to do? We are going to find the square root of both sides. So we're going to find the square root of L squared, which becomes L. Once I put my square root symbol above L squared, that power of 2 by L then disappears. So your power of 2 will no longer be there, it becomes L. And if with an equation, what you do on one side, you must do to the other. So I'm going to find the square root of 83.93. The square root of L squared becomes L. And let's find the square root of 83,938. So the square root 83,938 will give me 289.72 kilometers. And did they ask us to approximate anything? No. So what we're going to do is if you want, we can put it to the nearest whole number, right? Because those two lengths are whole numbers, so we can put it to the nearest whole. So you look at the first digit after the decimal point, which is 7. Once that digit after the decimal point is 5 or more than 5, we're going to add 1 to the unit of the whole. So your 9 there will become 10. And the 1 and 0 from your 10 will have a purpose. The 1 I'm going to add to my 8 to become 9, and I'm going to replace the 9 with 0. So this here, L or RT, I'm going to change the L now back to RT because L is RT. So my common L, which is RT, will be equal to 290 kilometers. So the length of RT is 290 kilometers. Good? So this is using the cosine rule. So again, we have to make sure we can use the cosine rule to find the length of a side. We can use the cosine rule to find the size of an angle. Alright? And let's look at the other part of this question. Right, determine the bearing of T from R. Determine the bearing of T from R. So, let me erase all this information here. So we got the length of RT. So let me erase all this. And they want us to now determine the bearing of T from R. Right? So part 3. So determine the bearing of T from R. Good? So the bearing, what's a bearing? A bearing is an angle, right? And what the bearing of T from R. From R. So from R, what you're going to do? You are going to set up your north line. This is T here, that is R there, what the bearing angle of T from R. So from R, I set up my north line. See the north line at R? That's my north line. And the bearing, of course, I must move in a what? Clockwise direction from the north line all the way around to the line connecting T and R. So this is the bearing here. I'm moving in a clockwise direction. Wow. So that is the bearing. That's the angle I need to find. Good? So how am I going to find that bearing? Oh. Very important, right? So to find that bearing, what are we going to do? Now, now the thing is to find the bearing. If you look, this here is an entire circle. Right? By put that dotted line there, we have a full circle. Not so? And I know that this angle within that full circle, let me put it in black. Right. So I know that this angle here, right? So we have this bearing we need to find in red. So we have this entire angle here in black. Good? So the angle in black is divided into two angles. This angle here and this angle within the triangle. So the angle outside of the triangle, this angle here, between the north line and RL, this angle here, NRL, that angle, we can't find. You know why we can't find that? Because we have two north lines, and therefore those two north lines are what? Parallel lines. And if they are parallel, then we have a transversal, which is RL. And we have this box shape. You see the box shape here? So we have this here. We have this box shape here. So we have N, we have N, this is L, this is R. You want to find this angle here. You have this angle here, which you know is what? 65 degrees. Good? So this angle, NRL, you can't find. NRL, let's find that. Good? So, we're going to find angle NRL by angle NRL will be 180, subtract 65, and 65 from 180 will give us what? 180 subtract 65 will be 115. So this angle here is 115 degrees. And we'll give the reason for co-interior angles. So this angle here is 115. Alright? But what we need to do now is find this angle in the triangle. You see that angle in the triangle? When I find that angle in the triangle and I add that to 115, then I can subtract the sum of those two angles from 360 to me to find the bearing of T from R. Good? So I need to find that angle in the triangle, and this is something you need to pay attention to, right? So to help us to find that bearing of T from R, which is the arc in red, we need to also find this angle in the triangle. So we can add that angle to 115 and subtract it from 360. So the question is, how are we going to find that angle in this triangle? Now you can use one of two things, you know. We can use the cosine rule, you know, because you have all three sides. To help you to find that angle there. So you can use the cosine rule if you want, right? But you can also use the sine rule. Okay? And the reason why you can use the sine rule also because we have an angle as well in the triangle. So besides, now the cosine rule will be used if and you can use the cosine rule, yes, because all three sides are known in the triangle. But the sine rule can be used here also because we have an angle as well in the triangle. So besides the three sides, we also have an angle. So therefore, the sine rule can be used to help us. And what is the sine rule? Let's make sure we know what the sine rule. So I'm going to put here in part 3, I'm going to state here using the sine rule. So we're using the sine rule to help us to find this angle in the triangle, which will then add to 150. So let's find that angle. So the sine rule is about ratios. A ratio is a fraction, right? So the cosine rule is no ratios. Make sure you know that, right? Make sure you know your cosine rule. And of course, both sine and cosine rules can be found in the formula sheet of the CSEC exam paper. But the sine rule is about ratios. The sine rule is like this. If I have triangle A, I have ABC. This side will be common A, this side is common B, this side is common C. And if I have this angle at A, this angle at B, and this angle at C, the sine rule is about ratios. So this is the sine rule. Make sure you know it, it's in the formula sheet. It's going to be common A over sine the angle, the corresponding angle at A. So that's a fraction, that's a ratio. Is equal to what? Common B over sine the angle at B. So sine common B over sine the corresponding angle over sine the corresponding angle at B is equal to common C side common C over sine the corresponding angle at C. So 3 ratios we can get from that triangle there. But in using the sine rule, we use only 2 out of the 3 ratios, right? What are the 2 ratios we can use here to help us to find this angle at R? Good? So this angle here, right, is at R, and what will be the ratio? Now, the ratio is simply this. Let the first ratio, when you're using the sine rule, let the first ratio always be the ratio with the unknown. The unknown is the angle at R. Alright? So this angle here, it's at that vertex R. Good? R there will be the fixed point of that angle. So let the first ratio always involve the unknown. So your first ratio, because the angle is at R, let the first ratio only involve R. So it's going to be what? Common R over sine the angle at R. Only R? Only R. So common R over sine the angle at R. This angle you need to find here. See this angle here? This is what you want to find. So that first ratio has the unknown. So let the first ratio always have the unknown. And let the second ratio be a ratio where you have information for both side and corresponding angle. So when we look at that triangle, which side do we have information for and corresponding angle do we have information for? It's going to be what? Common L over sine the angle at L. So common L, we have information for that side, and the corresponding angle at L, 83 degrees, we have as well. So you can let your other ratio be common L over sine the angle at L. That's the sine rule. So we use the sine rule about ratios using the sine rule to help us to find this angle here. We can also use the cosine rule to help us to find it as well, right? So let's put in the information that we have. Common R is what? 180 kilometers over sine the angle at R. That angle at R, sine the angle at R stays as is. That's your unknown. Is equal to common L, which is what? 290 over sine the angle at L. Corresponding angle at L is 83 degrees. So what are we going to do here now? You have fractions. You never work with fractions and equation with fractions. You have one fraction on the left, one fraction on the right. So to remove it from the fraction, you can cross multiply. So this will be 180 multiplied by sine 83 degrees is equal to what? 290 multiplied by sine r. Good? We want to get sine r by itself before we find the angle at r. So you need to get sine r by itself first, then you'll find r. Good? How am I going to get sine r by itself? This 290 have to go. That must go. So I have to remove 290 first. So, how am I going to remove 290? This is 290 multiplied by sine r. So the opposite of multiplication is what? Division. So this will be 180 multiplied by sine 83 degrees. This will be 290 multiplied by sine r. So I'm going to divide, I need to remove my 290, so I'm going to divide 290 by sine r by 290. And remember, an equation is about balance. So what I do to one side, I must do to the other. So what will happen here? My 290s now will divide into each other to give me 1, and I'm going to be left with sine r. And on the left side, I can work that out. Left will be equal sine. That's 180 multiplied by sine 83. And I'll put that in brackets. So brackets 180 multiplied by sine 83. Close brackets divided by 290. 0.6160. 0.6160. And therefore, to get r by itself, I'm going to remove sine. So that sine will come across to the right or left of the equal sign. To get r by itself, that sine now comes across as sine inverse of 0.6160. And you're going to get the angle r by itself. Now you could have used the cosine rule, it would have got the same result. So sine inverse of 0.6160 will give us what? 38.02 degrees. 38.02 degrees. So this angle at r, and I'll put it to the nearest whole number, I'll write it as 38 degrees. Right? Is equal to the angle at r. So this angle at r here is 38 degrees. That angle in the triangle. So we have to find that angle in the triangle. We have to find this angle NRL. Good? And having found those two angles, and again we found that 38 degrees using the sine rule, you could have also used the cosine rule because you have all three sides. Good? And now, to determine from this question the bearing of T from R, we are going to add 115 to 38 and we subtract that from 360 degrees. So therefore, the bearing of T from R the bearing of T from R will be what? 360 subtract 115 plus 38. Alright? And 115 plus 38 is what? 153. 360 subtract 153. 207 will be the bearing of T from R. So 207 degrees will be this bearing. Alright? So that will be our bearing of T from R. Okay? Yeah? Alright. So So I'll probably do one more circle theorem question just to make sure we're clear on our circle theorems. And we're gonna call it a night, right? Alright, I'll do this one because I want us to do a circle theorem where parallel lines can come into play, and you'll see sometimes where the isosceles triangle, the isosceles triangle, which we know will come into play as we saw in previous examples. But we have a big isosceles triangle here, not at the center, meeting at the being created at the center from the two radii, and then you have a chord node. We have a different case here where the isosceles triangle will come into play, right? So let's look at this. Right, so this is June 2022, question 9A. So let's look at this question. H, J, K, L, and M. So H, J, K, L, M are points on the circumference of a circle with center O. MK is a diameter. So diameter, line drawn. We'll cut your circle into two semicircles, alright? MK is a diameter of the circle, and it is parallel. See, it is parallel, that's why I have those two arrows. It is parallel to HG. Right? So they are parallel. See the arrows showing that they are parallel. These two arrows here. Right? So they're parallel to each other. Arrows moving in the same direction. MJ and JL are equal. So this line here, or this side MJ, is equal to this side JL. And the two little strokes there will indicate that these two lines are equal. Which will tell us that this triangle here, JML, is an isosceles triangle. So that should stand out one time. And what should also stand out is the fact that when I have two lines that are parallel, which we just saw in bearings, alternate, corresponding, and co-interior angles can come into play. So you see where it can come into play with your circle terms as well, right? Now angle JMK, JM is at the middle, so fixed point between JM and MK is 38 degrees, you can see, right? So what I want us to find in this question. Explain the reason why angle HJM is 38 degrees. Where's angle HJM? HJM is 38 degrees. This angle here. HJM. Why this angle is 38 degrees? And look at why it's 38. Because these two lines are what? Parallel. So what angles can come into play? Your Z shape. Alternate angles. This angle is equal to that angle. So look at the Z shape here. Z shape. So this angle is 38, then we expect this angle here to be what? 38 degrees. So for that first part of the question, explain the given reason. So angle HJM is 38 degrees, and and the reason will be for alternate angles. Good? And then they have, they also want us to give reason why angle MJK is 90 degrees. Let's find angle MJK. So this is A. Let's look at B. MJK. Show why that is 90. Show. Good? I'll explain why it's 90. Now first, let's make sure we know where is angle MJK. Good? MJK. J will be the fixed point between two lines, MJ and JK. So we're looking at this here. MJK. This is the angle MJK here. Good? Now why is MJK 90? This is the reason. Because when you have a circle, let me pull it out, you have center, you have a diameter. What the diameter will do, the diameter will divide the circle into two semicircles. Alright? And what the diameter will do in one of the semicircles is subtend an angle at the circumference. Alright? So the diameter is going to create. So a line drawn from this end of the diameter, this is what? M, that is K. So each end of the diameter, a line drawn from end to the circumference, from K to the circumference, both meet at J, and therefore this angle here is 90 degrees. Good? So angle J, MJK, MJK is equal to 90 degrees. And what's the reason? The reason will be angles in a semicircle. An angle in a semicircle is equal to 90 degrees at the circumference. Subtended, remember subtend means to create, subtended by the diameter. Right? So I'm going to write here angle MJK is 90 degrees because we're going to state here, this is the reason, angles, one angle in a semicircle is equal to 90 degrees at the circumference. Is equal to 90 degrees at the circumference of the circle subtended by the diameter. Alright? So that is 90 because the angle in a semicircle, as you see here, is equal to 90 degrees at the circumference of the circle subtended, created by the diameter. Alright? So that's why it's 90 degrees. So they ask us to explain, so we explain why it's 90. And make sure you know that rule, because that is also another common rule you see. And of course, we found HDM because of alternate angles, right? So let's move on to the next part. Right, so we have three more parts. So let me erase the one. Let's find angle MLG. MLG. So let me erase this. So MLG. So where's MLG? M. What part is that? part 2a, right? MLJ. What is a final angle? First, let's recognize this angle MLJ. Looking at the letter in the middle between ML and JL. So looking at this angle here. So we're going to find that angle. So we're going to find that angle using two things. Alright, I'll put out the two terms that are applicable here. The first is this, which we just looked at. Circle diameter subtends an angle at the circumference of the semicircle. This is 90 degrees. This is M, this is K. Right, so let's pull it out from the diagram. You know this is 90 here. You know this is 38, and we can find this angle here in that triangle. So you see this triangle here, this is 38. So I can find this angle in that triangle. So I'm going to find that angle first. So to get that angle, it's simply 90 plus 38 from 180. So I'm going to say angle, this angle here, JKM. This angle here, I'm going to call it JKM, is equal to 180 subtract 90 plus 38. 180 subtract 90 plus 38 from 180 will give us what? 128, 180 subtract 128, 52 degrees. Okay, so this angle is 52. So the objective of this question is to find angle MLJ, which is this angle here. So how are we going to find that angle? And we're going to use this term to help us to find that angle. Circle. This is my what? Chord. And I'm going to put the chord MJ. You see this is your chord from M to J. And what that chord will do, this is the theorem. The chord will divide the circle into two segments. So this is your major segment, this is your minor segment, two segments. And what the chord will do, the chord will subtend this angle at the circumference, which is what? K. And that same chord will subtend another angle at the circumference L in the same segment. Good? So the chord will subtend two angles at the circumference. Now what subtend means to create these two angles at the circumference in the same segment. Pay attention, you should pay attention to that very important theorem. And once that occurs, if this angle is 52, this angle is also 52. Angles in the same segment are equal at the circumference of the circle, subtended by the chord, by the same chord. Alright? So we can simply state here that angle MLJ is equal to 52 degrees because angles in the same, when they ask us to give reason, let me see if they ask us to give reason. Right, so show you the tail working. So this is the tail working here. They didn't ask you to give reason. Let's just show the tail working, alright? So this is your detail working. You found the angle JKM first to be 52, and therefore angle MLJ is also 52 because of that very important theorem there. Alright? So you don't have to give a reason, but show the tail working. Alright, let's look at the next part of this question. So we have two more parts, and then we're going to come to a close. Angle LJK. Where is angle LJK? LJK. LJK. So you want to find that angle. So we're looking at B. Angle LJK. So you're looking at J, which is at the center at a fixed point between the two lines LJ and JK. So you're looking at this angle here. This is angle LJK. So that little angle there, that is angle LJK. That little angle there. And let me erase this. Let me leave it. So angle LJK is that little angle there. Good? So how are we going to find that angle? Yeah? How are we going to find that angle? So we can find that angle because if you look, this here, see this big triangle here? That big triangle is an isosceles triangle. So let me pull it out. This big triangle here is an isosceles triangle, which is so we see them J, L. These two sides are equal, so it's an isosceles triangle, right? And for an isosceles triangle, this here we just got this in the 52. So for an isosceles triangle, base angles are equal, so this angle here will also be 52. So you see this angle here? If this is 52, then this angle here is also 52 degrees. Good? And if that's 52, then what you can do is find this little piece inside here. That little angle inside here. We can subtract 38 from 52, and 38 from 52 will give us what? This will be 14 degrees here. So you see that little angle there? That will be 14 degrees. And therefore, if that's 14, we can use this same angle here, the same rule. So this here consider this to be an imaginary chord. So this is your chord here. Imaginary chord, we're not seeing it, but we can connect a line from L to K. And what's going to happen? This chord will divide this circle into two segments. Major segment, minor. And look at what the chord will do. The chord will subtend an angle at the circumference in your major segment to give you M, which is that 40 degrees there. And that same chord will subtend an angle at the circumference at J in the same segment. So this angle here, see this little angle here? This little angle here will be equal to 14 degrees. Because the chord subtends this angle at the circumference here, which is 14, and the same chord subtends an and create another angle at the circumference, which will also be 14 degrees. Alright? So your reason will be, you can give the reason by stating that I'll start off by saying that angle JML is 52 degrees. Angle JML is 52 degrees, and that will happen because of what? That will happen because of it's an isosceles triangle, and therefore angle LMK is 14 degrees because we subtracted what? 38 from 52 to give us 14 degrees. And therefore, because of the theorem which deals with angles in the same segment are equal at the circumference subtended by the same chord, yeah, we can state that angle LJK will also be 14 degrees because of that important theorem. Angles in the same segment are equal at the circumference subtended by the same chord. Alright? So that angle is 14 degrees. And let's look at the last part now. Angle JHM. What is angle JHM? JHM. So JHM will be easy to find. Right, this part would have been a bit challenging because I'm sure students would not have seen clearly the that theorem, angles in the same segment are equal at the circumference subtended by the chord, same chord. But to find angle JHM, so JHM, make sure it's JHM, yeah? JHM, we're using this, so we want to find angle JHM. Alright, and this part is part C. So JHM will be equal to what? Let me pull it out. Circle. This is my I'm sure we can comfortably see it. You see the isosceles, the cyclic quadrilateral. So we see the cyclic quadrilateral here. See that shape, there is a cyclic quadrilateral. JHML. That's a cyclic quadrilateral there. So JHML is your cyclic quadrilateral. And if this is, and this is the angle we need to find, JHM. So this angle we need to find here, JHM. So to find that angle and knowing that this is what? This angle here is 52 degrees. Knowing that angle is 52, I can find JHM by subtracting 52 from 180. So angle JHM is equal to 180 subtract 52, and 180 subtract 52 will give us 128 degrees. Because opposite interior angles of a cyclic quadrilateral are supplementary. Good? So that's how we got it. So let's make sure that we can recognize our theorems. Let's make sure we know them. Yeah, you have to make sure you know those terms. So review them, please. Make sure you do questions where you can recognize the theorems. Remember, the isosceles triangle will also come into play with these questions. Alternate corresponding co-interior angles for lines that are parallel will come into play with these questions. Alright, make sure you know your bearings, understand what is a bearing, an angle. We must set up a north line, move in a clockwise direction from the north line. And with your bearings, remember the sine rule, cosine rule, along with the application of those angles, alternate corresponding co-interior angles. Right, so this will bring us to the end of this session. So tomorrow will be the last session before exams. So have a great night. See you all tomorrow. And don't forget to like, share, and subscribe to Moyo Man. Right? Have a great night. Take care, everyone.